Once we have determined the question we want to answer and developed a hypothesis to answer that question, we need to plan our experiment. So the important thing about the scientific method is that it is a well-defined process, and a good scientific experiment is going to have a specific set of variables and a way that we design our experiment around these variables to ensure that the data that we collect reflects the impact of only the factor we are testing. And so there are a few considerations when we plan our experiment. So an experiment is a scientific test performed under specific circumstances. You probably all know what a scientific experiment is. You've probably done one at some point in your life. You've probably learned about the scientific method. You've probably even had another class recently where you have learned about the scientific method. But there are a few important factors for designing our experiment. The most important is that our scientific experiment is a controlled experiment, meaning that you want to limit outside impacts. So as best you can, you want to ensure that the only thing affecting your results is the one specific variable that you are testing, the one factor that you think is the cause for the question you are trying to answer. So we do this by setting specific controls in our experiment, conditions that are going to limit outside influences. We're going to always establish a control group. Now, the control group is usually the normal or the non-treatment group. It's going to be used as your comparison to see if you make a change, whether or not that change has an effect. And so it acts as your baseline to say, with no changes at all, as is the way it's been going, this is the data I'm going to collect. And then you can compare your control group to your group to which you have applied your certain set of conditions to see if something has changed. And this is really, really important for a valid scientific test because you need a comparison so you know if you've actually affected a change. The alternative to the control group is the experimental or the test group. Now, your experimental group or your test group, to the best of your abilities, should only differ by a single factor, that factor that you are testing. So you want to limit those outside impacts so that as best you can, there's only one difference between your control and your experiment, because you want to isolate that single factor as the cause for any changes in your data. So once we have defined our control group or our comparison group and our experimental group to which we are going to change a specific set of parameters, we also want to define our independent and our dependent variable. So the independent variable is always the one that you, as the researcher, have control over. So this is the condition that you are going to change. So in a previous video, I talked about the question, what causes leaves to fall in autumn? And the hypothesis was that shorter days cause those leaves to fall. Now, in this case, those shorter days are going to be the independent variable. Now, you can't control the sun, but you can control when you take your measurements. And so for that hypothesis that is sort of our theme through this section, the independent variable is going to be the amount of sunlight, or the hours of sunlight. The dependent variable is going to be the variable that is affected by change. So in that example, what causes leaves to fall, our dependent variable is going to be the amount of leaves that fall. In other words, your dependent variable is going to be the data that you collect. It is the factor that is affected by what you are changing. So this example here, we have 3 different pots of plants. And so I would imagine that the question is, what factor affects plant growth? So the hypothesis might be that the amount of water affects plant growth. And so your independent variable is going to be the amount of water. And you're going to give some plants a normal amount. That's going to be your control group. You're going to give some plants more and some plants less. These 2 are going to be your experimental group, and you're going to compare them to what you would normally water your plants. Now, the dependent variable is going to be the effect of that water on the plants. What you measure is up to you. You could measure the size of the plant, how big it gets, because you can measure how tall it is. You could measure the number of leaves that it has. You could even make an observation about whether or not it is living or it is dead. These top 2 are going to be quantitative data, and we really want to try to get number values from our data. The other one, living or dead, would be qualitative, and that's okay, but you really want to try to get quantitative data that you can use as specifics. You can perform statistical analysis on it, and that's going to give you a better understanding of your information. Living or dead is not very subjective. It's either alive or it's dead, but there are different levels of living, and so size or number of leaves might be better for this particular experiment. So we always need to define our independent variable and our dependent variable, and those 2 variables are really important for our hypothesis, which we should have already formed, and for our prediction, which we will talk about in the next video. So I mentioned control groups already. The control group is going to be your normal or your comparison. The control group could receive no treatment. So for example, if you are doing a drug study and you want to evaluate the effectiveness of an herbal supplement on the length of a cold, you might have a group that doesn't receive any treatment for their cold, and then they would be your control group or your comparison group. Sometimes there isn't a no treatment group, and that's just going to be whatever the normal condition is. So if you're looking at the effect of the amount of water, you have to water your plants. You have to set what that normal would be. That would be your control group. Your experimental group is going to be your test group, and they are going to receive a treatment that is different. Everything else should be the same. So besides that experimental treatment, your experiment should be the same. So other than the experimental group, all variables should be the same. I changed my mind about how I was going to say that mid-sentence. So your experimental group should only differ by that one variable. What that means is that the amount of soil in the pot, the quality of the soil in the pot, the size of the pot, the amount of sunlight that they're getting, all of those other things should be consistent and the same across all of your groups, because you want to make sure that it is only the amount of water that is affecting those plants. When you have outside variables that could affect your data, we call those uncontrolled variables. So for this plant example, we have things like soil quality, amount of light, and a few others. And these are all things that you probably know can affect how well a plant grows. These are also variables that you can control. Now, these variables come by a couple of different names. They might be called controlled variables because the experimenter limits what those variables are. They might be called experimental controls. Please try not to mix them up with experimental group, control group, because I know they all sound a little bit similar. But those controlled variables or experimental controls are the conditions that remain the same throughout the experiment. So these are anything that might affect the outcome of the experiment. If you already know that soil quality is going to affect how well a plant grows, you want to make sure that's the same so that everybody is in the same quality soil, hopefully good quality, so you get the best results. But you then know that soil quality is not affecting your outcome of your experiment. So you want to limit how many controlled or the effects of those controlled variables. An uncontrolled variable are these factors that could affect the outcome of the experiment, but you either cannot control or for one reason or another choose not to control. So you have to acknowledge that those may have affected your outcome. So for this plant experiment, maybe you have only a small amount of room on the shelf by your window, and one of your plants is getting a little less sunlight than the others. And there's nothing you can do about it because there's no other window available in your laboratory. Okay, so you've chosen not to go find another window somewhere, but you have to acknowledge that that plant receiving less sunlight may have different growth that has nothing to do with the water amount. So you want to make sure that you don't have those uncontrolled variables, but at the very least, you have to acknowledge that they may have affected your outcome. And as you're interpreting your data, you have to keep those in mind. Uncontrolled variables are important because they always reduce your confidence in your results. Because you don't know how much of an effect is from the uncontrolled variable and how much is from your experimental variable. So if you have those uncontrolled variables, even if your data makes sense, even if there's less difference than you expect, you have to acknowledge them and you have to explain that your confidence is reduced because of those results and because you don't know how much of an effect they had. Does not mean that your experiment is invalid or that your results are wrong or that you haven't supported your hypothesis. But a good scientist is going to acknowledge the limitations of their experiment and address those as they are deciding whether or not they have supported their hypothesis.